Hello everyone, I'm Wenxin, a research scientist at Google. Today I'm going to introduce HGaze typing, a text entry interface that combines head gestures and gaze input. Why we want to combine gaze and head input? Let's first see the advantages and disadvantages of these two inputs. First of all, gaze input is known for its speed. Eye movement is fast and allows rapid saccade between fixations. In addition, eye movement involves few muscles, so gaze input can reduce the risk of fatigue or cumulative injury caused by long-time usage of computing devices. However, the noise of gaze input can be problematic for fine positioning tasks. There are two sources of gaze input noise. One is the involuntary eye jitters, and the other is the noise from eye trackers. Gaze input also faces perception and control dilemma. That is, eyes are perceptual organs rather than control organs. When a user is performing a control task, such as dwell time selection, the user cannot perform visual tasks, such as checking the entered text. As for head input, stability is one of its advantages. Also, when performing commands with head tracking system, user can simultaneously receive visual information or feedback with their eyes and perform actions with their head movements. However, head input is slow, and when using head tracking system for long, user will feel fatigue. Based on the characteristics of head and gaze inputs, we derived three design principles. First, using head gestures to perform tasks requires high accuracy. Second, using head gestures for commands associated with visual activities. And third, using gaze inputs for tasks that can benefit from fast movements and only requires the coarse level of accuracy. Let's apply the design principles to gaze path-based text entry interface. And this kind of interface consists of 5 tasks. The first one, initiating or finishing a word pass by selecting the first letter and last letter, and that requires accuracy. We will use head gesture. And second, connecting the middle letters of the desired word to generate path, and that only requires coarse level of accuracy, and it also will benefit from speed. So we use gaze input. And third, canceling a path when it started involuntarily. So that will require accuracy. We'll use head input. And fourth, choosing a word from a candidate list. And that usually associated with visual activities. So we will use head gestures. And 5, delete an unwanted word. And that's also associated with visual activities and also requires accuracy. We'll use head gestures. So what kind of head gestures will we use? A nodding gesture is faster than the other head gestures and is considered the best head gesture for making a selection. So we assign the nodding gestures to starting and ending a gaze path task. We use a head shake, or defining as rotating head to the left or right to word deletion. Word path canceling is a similar concept as deletion, so it's also assigned with the shaking task. As for selection of candidates, we use tilting gestures. The direction of a tilting provides easy navigation on the word list. Let's take a look at the HGaze typing interface. Assuming that we want to type the word gaze, we will first look at the letter G, and then the red dot demonstrates the fixation. And the user can perform a nod to select the letter G, and the boundary disappears and the word path starts, and the user can quickly scan through GAZE and performing a nod at the last letter E, and the candidate list will show above the key, and gaze is entered in the text box. If the user is okay with gaze, and then the user can perform a next word entry. If not, and the user finds the desired word in the candidate list, the user can tilt its head to left or right to select. Say great, give, and that will show in the text box. And if the user didn't find the desired word, the user can use shaking to delete the word. For system design, we have two algorithms: fixation estimation and head gesture recognition to process the gaze and head movement data. And we design 4 status in the system. And the most important part is the down gaze lock and gaze path restoration. So when the system detected a downward head movement, a gaze lock is activated to prevent the gaze shift due to a potential nod. Once a nodding gesture is completed, the gaze position information is unlocked and restored for gaze path classification. We propose the gaze lock mechanism and the gaze path restoration algorithm to minimize effects of gaze shift for head movements. We use Frechet score to compute the word candidate list. And when we detect nodding, shaking, or tilting gestures, and then the corresponding command will be activated. We conducted a user study with 10 participants to compare HGaze typing with a baseline dual-time keyboard. Tobii Eye Tracker 4C was used to collect gaze and head input. Each participant typed about 20 phrases every day, and the experiment spans in 3 days. Overall, the mean text entry rate using HGaze typing was higher than using the dual-time keyboard. In the last 3 sessions, a significant effect of interface was found, with an average typing speed of 11.22 words per minute for HGaze typing and 9.53 words per minute for the dual-time keyboard. The mean number of deletes and cancels when using HGaze typing is shown here. The average number of deletes reduced from 1.75 in session 1 to 0.57 in session 9, and the number of cancels reduced from 1.05 to 0.6. HGaze typing has a higher perceived performance score and is preferred by participants. Participants like the concept of using various head gestures, especially the concept of using the tilting gestures to select words. One participant indicated that the nodding, glancing through the keys, nodding pattern creates a rhythm for this bimodal text entry interface. To conclude, HGaze typing achieves a better text entry rate compared to dual-time typing and is more comfortable to use. Head gestures provides natural and efficient command activations and free the eyes for other visual activities. HGaze typing manages the processing of the gaze and head inputs in one system without interference. And HGaze typing design reduces the virtual keyboard area by putting the candidate list between the keys. And the design model that uses gaze path plus text entry command can be extended to other devices.